All right, good morning. Saturday. Got Windows previews straightened out. Live indicator. All right, let's side. Oh, so it must be. Okay. That sounds, so let's put that stuff back. All right, good morning to everyone. Let's turn the preview in. My name is Tim. I go by FoamyGuy on GitHub and Discord. We are picking up this morning where we left off last night on ESP32SPI socket file downloading. If you're catching this on the video in the future, or if you happen to be watching live and you have no idea what I'm talking about, basically we are working on stuff related to CircuitPython. CircuitPython is an implementation of Python that can run on tiny computers called microcontrollers. These devices will connect up to your computer. You can run Python code on them, and then they can interact with other peripherals, other things that are connected to them, such as, for instance, like Wi-Fi radios or keyboard switches or screens or knobs, or really any kind of like electronical doodad, touch screens, all kinds of different things that you can hook up to these microcontrollers and then control from this Python code. So this is kind of like the high level thing that we are working on. More specifically, today, we are continuing on what I was doing last night, which is on these devices like the PyPortal. If we head over to the Adafruit website, we can actually see a picture of the back of it because I don't have camera going yet, although we'll probably want to get that going at some point. On the back of this device, it has not only a microcontroller that runs CircuitPython, this one in the middle here, it also has this secondary microcontroller over here, which is a Wi-Fi specific microcontroller. I think it does Bluetooth as well. I should say wireless communication specific microcontroller. And on this device, the PyPortal, this one is Titano. There's a couple other sizes of them as well. The main computer talks back and forth with the communications computer, which allows it to have access to the internet. It can send requests to things on the internet, connect to sockets, do all the things that you can do with stuff that are connected to, I should say, networks, not necessarily the internet. You can join a Wi-Fi network that is connected to the internet. You could also join a Wi-Fi network that is just local if you wanted and send requests across that. Specifically within the library that controls, that handles the communication between these two things, we are kind of trying to get into a state where we could accept this refactoring of that library to make it behave more like the CPython socket class. The thing is that initially when that refactoring was attempted, there are certain things that get downloaded in this weird chunked out blocky way. So Ultimately, we need to try to fix it to where when you download things with this newly refactored version of the library, that the downloads do not do this. They download correctly instead. Where we left off yesterday was we were kind of lost in a stack of different functions. We're gonna open up a bunch of these things. So we want requests, we want PyPortal. Open this one. This is a Mac screen. What is this? Let's see. How's it going, C. Grover? Good morning. Got the coffee right here for me. Going iced this morning. We can open it easier with recents, actually. Yep. So, base. ESP32SPI, I guess. Yeah, we may. I don't know if we'll need right now, truthfully. The thing is, like, the change has been made inside of there. Our goal is to change the stuff outside of there to make it work with the changed version of that. So we may not end up actually needing it open. We'll see. I'll open device workspace so we can talk to the device, which I will plug in as well. Okay, so we had Cleveland Museum of Art project, but we were also just using a smaller version that only does fetch one thing. I did not ever, I guess, change my CodePy over to that smaller one. So CodePy right now is the full Cleveland art project, which actually I should have looked on my device for before we started this. I actually have an old version of it. What I'm going to do is copy from CodePy and paste into Cleveland Art. These are probably the same, but just in case there were any changes in Cleveland Art, we want to get those and save them in there. And then inside CodePy, I actually want to put fetch test, which we made yesterday. That way, because this is like a more minimal program. It will only download one thing. It will not try to keep going on a loop. Decide if I like the camera on the right or the left better. How much of the camera do we cover up? Kind of a lot. Yeah, I guess we should go with the left. Oh. Usually when I see that kind of thing happening, it's because I either like have my hand on a keyboard or like something is fallen on a keyboard. So for a second I thought something was just sitting on a key somewhere, but it just prints those while it downloads. That's fine. Okay, so we were deep in it. I do have a notes file with like where we were at. So I think after resting on it a bit, I'm thinking inside, I guess here maybe is where we might start finding the code we're looking for, which is the code that's essentially kind of like compiling together this response object, which in our case is supposed to be a BMP image that got converted from a JPEG image. We need to find that code that's responsible for like reading over and over again in order to build that thing, and then we're going to need to build some logic into it to essentially do the stuff that was removed from ESP32SPI. So inside of requests at line 700, we create a response object. This is in the request function, I think on session, but I'm not positive. So we create this. Then if there are redirects, we handle those, which includes the only place where we actually reference stream. So that was another thing I think I discovered in this process, is that stream might be getting ignored. But actually, that's the thing I wanted to test out now that I say it out loud again. We want to... I'm not actually calling it with stream here. But I guess PyPortal, is it under the hood? Maybe it is. Yeah. Where's this come from? Are we using stream right now or not? And then I want to try it the other way if we are. Really, I want to try it the other way no matter which way we're using it. We are calling wget. This is inside of like process network though. This is way too far up the stack. Where's our notes? This one is on the far right. That's going to be weird to get used to. Okay, PyPortal wget was back up here. That went into portal-based network wget, which was here, which ended up going into requests.get here. So do we pass stream true here or not? Portal-based 273 inside network pi. Do we pass? We do. Okay, I want to try to change that and see what happens. Maybe we run out of memory. That's very possible. We need to edit it on the device, inside portal-based network pi on the device. Portal-base is in the root because it is frozen in, and we want to use our modified version instead. And this was where? 276? 73. .280 actually. False, and then run this again. Probably we run out of memory. No. Maybe. I mean, no. It seemed like it succeeded, but then it immediately soft rebooted, I guess. Yeah, I don't know. Something wrote to it, I guess, probably. We should maybe turn off. I've been doing a fair amount of turning off the auto reload lately when I'm in the middle of iterating through tests like this, because I'm finding sometimes it's auto reloading. You know, one thing that is interesting is it looks different this time. The colors were more messed up last time when it did it a second ago. A little bit odd. What that means, or if it means anything. Okay, this time it did not auto reload, so that's nice. And it is still messed up, so stream doesn't matter. So that's one thing that is good to know, is that the stream true or false does not actually matter, and so the fact that it's not using it seemingly not going to matter either. Back into here though, where we create the response, inside requests around 700. I want to get inside of here, so this is inside requests 178, so this is about where we left off. And here it's init. We need to put init, I guess we could. What's happening in here? So we do have the sock here. It says it's a sock type, maybe? So is it not the actual instance itself, but instead only the type? Possible, I'm not sure. Maybe sock type is just because there are multiple available types. Maybe that's an alias for all the possible types, and it is actually an instance of one of those types. That could be. Receive into. Okay. Read up to the first space, I'm pretty sure is what this means. Not HTTP. So if that failed, if we have none, I guess, we have a falsy value. If we had a session, close the session. If we didn't have a session, then close the socket. So this is like, I think, old style, new style, or vice versa. I think this is old style and this is new style. Because remember before we found that set socket, and in there it had a note that said it was deprecated and you should use sessions instead. I'm guessing that's what this is about. But either way, we failed the request here. We got a falsy data on our read to. I've also backwards compatible here. Doc has receive into. Do we have receive into still? This is where we're going to want to open ESP32SPI. I'm curious if that was one of the ones that was removed or changed or what. Fix receive into for far larger fetches. Socket receive into fixes. Does have receive into. And it did get changed. It got fixed. I wonder if this is talking about the behavior that was removed. Maybe we need to just set this the other way. So if this part this part failed, if that was falsy, then we're ultimately going to raise right here. If we go on, then that means that this was not falsy. It was truthy, so we got a good first read. We then read again to get the status code. So that's going to be like 200 or 404 or whatever. Then we're going to read again and get a reason. We read up to the end of the line after that. Then we call parse headers. We set raw to none. We set session to session. Which is what? Where did session come from? I mean, we have this here. It's really weird that right here we're like if session, but then down here we're just like, yep, session exists. Let's put it into here. That seems odd, right? Because session could be not. I mean, this implies session could be not, like none. And also up here it's set to none. So then if we got down to here, I mean, I guess we would just put none onto there. I guess some other part of the code, I suppose, is doing this kind of thing. But I feel like at the end of init, we still have not read the full response, right? Like, we read the status code, we read the reason, we read the HTTP thing at the top. I think this is probably meaning the verb, right? Like, well, no, that would be for a request, I guess, not a... Does it send you back? I don't know, actually, if it's the verb or what. Maybe it's the version of HTTP? I could try printing these things. I'm changing this in the wrong place. Things up. West. I want to see these run once, but I'll probably just take them right back out because they're going to change the line numbers. It's not ideal. We could also put stream back to true. The old version of the code? Okay, that did not have our changes in it. I edited requests inside lib. Is there one in the root? There is. That's annoying. Okay, let's delete the one in lib. That one's never going to get used. So delete the NPY. I mean, hopefully I put this in here yesterday. I think this is not crucial to get these things to print, but I'm curious what they are, like what part of the request they are, just to have my bearings on what has been read so far and what hasn't. By the time that response is finished. UTP 1.1, so it is the version, but also the HTTP, except the H is missing because it got taken out somewhere else. We found that before, I don't remember, but I remember seeing something check for the H. Status code is the number, and then reason is okay. We get reply is okay that came from somewhere else in our code, and then we start getting saving data. All right. I'm going to delete these so that our line numbers get inaccurate. So by the time that we get to the end of when response is created, we haven't really downloaded the full file yet. As far as I can tell. We could maybe confirm that by saying right here, end of response. And I believe we will see this before we see these things here. We need the actual spit after it starts doing this kind of thing. We need to keep tracing. So we created a response object. That was from line 700 inside requests. That was our init. By the time we get to here, we still haven't downloaded full file. But we are finished with init, so we're actually kind of jumping back to this one. So 700 in here. My line numbers are already off. Any chance I have the wrong version of requests? Should I stop right now and get a new version of requests? Fresh version. Yeah, I mean, I think so. Let's revert these changes here. Main and then copy main and over to root. That should also undo the change with stream true, I think, or was that in a different file? That was in portal base, actually. Yeah, never mind. That was in portal base, so that will not undo that. Sure that it still does the same thing it did a second ago. Yeah. Is it actually line 700 in this one? Yeah, it is. Okay. I don't know what the... Maybe I left the prints in that one? I don't know. No, somehow we were a couple lines off, but we're back to it now. 700 is here. What happens next? So let's assume that redirects are not involved. We just set last response equal to response, and then we just return response. And this was from request inside of the session. And at this point, we still have yet to download the file, right? Like, we're still not... Still haven't actually downloaded anything. I mean, we downloaded, like, the... I mean, maybe we have... I don't know if it's, like, in memory or if it's still... I don't exactly know where it's at, but we haven't started printing those dots and writing the file yet, which that's the logic where I think things are out of order, is inside that thing. Dots got me again. I thought I just said something on the keyboard. Yeah. So this is still here. This is in fact still before we have printed reply is okay. I don't remember exactly where that print was coming from, but we have not reached it yet. $577, but I said red herring because it wasn't getting Oh. Red herring just because it's not involved in reading the data back. This is only sending the request. Makes sense, right? It's called send request. So we go inside of this and then we come right back out of this, and we still have not done the part that we're interested in, which is the actual like reading of the full response. Print in here. End of send request. I'd have added an extra line to do that. I'm in the wrong place again. I don't know if I added an extra line there or not. Well, after 700 actually, which is the last thing I think I had, so I suppose it doesn't matter. Okay. Yeah. That's just red herring because it's not, I mean, it's not a red herring, it's just off the beaten path. It doesn't matter for the part that we're interested in. So that was here, which is where it called this. Yeah, so it would have called this and then came back, continued on, ultimately calling this here. And so we know that all this stuff back here, there's where the H came out, by the way. Oops. Why we were missing the H. But we know that we still haven't found the part that we're interested in here, so we need to keep stepping back. So this is inside of session request. It's 25. It's where this. So yeah, by the time we get all the way to the end of this, we still haven't gotten to the part we're interested in. So we need to find where we called this from. E29. Side of get. Default session request. And then this is just like only return, and there's like no room for me to add a print. I mean, I guess I could add a print, but it will happen before this it's called, so that doesn't really help us. I guess I could split it apart. I could give it this number. Still, all of that's before this, so let's put this back. Does the downloading occur? We still have not even downloading. This is inside of def-get. We're back up into Portalbase. So the actual downloading has still not actually occurred. Is that real? Portalbase Network Pi 273. Let's do it in, let's not look in the other repos actually. At these and just only look in the ones on the device. That way I'm not changing the wrong one ever. wget 73. Oh, this is a little bit off for some reason, but well, for one thing, I added these. This is still before our dots start printing, I think. It's really weird to me because that implies that you get all the way back from request.get, but you still haven't, you still don't have the full content of what you got. Feels weird to me, but I guess that's how it goes. There's our reply is okay. One thing maybe we should do is turn debug on. It's going to print a lot more stuff. Not sure where to do that. Hopefully it works if we put it on the this one here. Yeah, more prints. It's not going to print my network, is it? Hold on. No. Did print a bunch of extra stuff, like, well, that was the print we put in. They just look like all the headers. And at some point we will print saving data, and then we will finally start reading data. Yeah, reading over and over and over and over here. Actually kind of a lot of stuff. I'm going to turn this back to false because it printed a lot. Maybe we could eventually get it back to true if we need, but... response.iter content. Close. Okay. This is definitely where our download is occurring. There's our periods getting printed. There's our debug message that was spamming. So the behavior of iter content, which came back from response, says the smaller of the two between the remaining size and the chunk size, which was, I think, just like 512 or something hard-coded somewhere, I thought. Does chunk size change the anything about the appearance if I use a bigger one? Do we get like bigger chunks in the rectangle-y thing going on there? No, it looks the same. As far as like these bands are not any wider or anything. There's an extra like dark line there. I don't know. This bit maybe looks more out of order than before, but I don't know. Doesn't really like it made much of a difference. Response iter content. Say anything about iter content? Nope. So we'll need to be, I guess, back inside of iter content. So we are in wget, and we are at line about 311. So pretty much all of this was inside of here. And none of it was really the part we're interested in. The part we're interested in is still inside of here, so it's kind of like all of this is in, or yeah, this is all in, and then this is kind of here. What happens when chunk size is reduced to a small value like 64? Can try that. Currently still inside of this. That's interesting. So the color looks way more messed up, but the bottom actually doesn't look out of order. The color was not consistent every time. I don't know what's going on with the color. The color's weird. Yeah, that's actually downloading the file pretty well, honestly. So larger chunk sizes are part of the problem, seemingly. We are still having some weirdness on the color, but the color is starting to feel more and more random the more times I run this, because like we're not getting the same results with the color every time. And sometimes we have no parts that are messed up with color. But before we were always messed up in terms of like the out of order boxes or whatever. Still got one band messed up there. Yeah, it looks way better that way. Yeah, good call. Buffer length never reaches the chunk size limit. Length never reaches the chunk size limit. For I and iter content, I, it looks like, is I gonna be? I would argue this probably shouldn't be called I. I is like, I think of it as I should be a number, right? Just counting up. This is, it's looking like the data, I guess, the chunk of data that it's reading during this iteration. Response iter content. So where do we find that? That's going to be back in requests, and it's going to be on the response object. The chunk value is large. When the chunk value is large, then that's when the buffer length never reaches the chunk size limit. But when the chunk size limit is small, reason it can do it correctly. I'm a little unsure of how, like, what the chunk size, I don't really know what that's doing. I mean, conceptually, I assume it's like how big of a chunk it's reading from the network and writing to the disk at a time, but I don't know any more particular inside of that, how it's doing it or what it's doing. That's what we're about to find inside iter content, though. So here's response. Into underscore. So this is a backwards. This is really, this is related. This is exactly what was changed. Exactly what was changed. I really think, I really want to try. I think if we flop this, we might have a chance of it just working. Where do we flop this though? So currently it gets set to equal to not has adder receive into. What value are we coming up with? Chunk size need to be tuned to the image horizontal line length. Good question. I don't know. Rather than a set to a fixed value. Yeah, I don't know. I don't think so, because I mean, the way that the ESP32SPI socket was working before it was able to do it, it just had like some non-standard code inside of it. Really, like the main thing we want to be doing here is taking that non-standard code that was inside ESP32SPI and moving it into probably portal-based network. We're trying to like move it up by 1 or 2 layers so that it's inside the portal-based thing, so that the actual socket at the ESP32SPI socket layer, it will be, you know, part for part compatible with CPython. Backwards compatibility is set to true here. Okay. I mean, what if we just turn it to false? Seems potentially reckless and dangerous, but are you gonna learn if you don't set a few variables to false every now and then, you know? Gotta be done. The stream suddenly cuts out and you never hear from me again, you'll know that it was not a good thing to set this to false, but probably that won't happen. I should also be showing the screen, I guess. And also, I suppose we should be using the, oh. That was anticlimactic, it just fails because it says it has no that. Fake SSL socket. Inside of receive into, which is where we were a minute ago. $28? Yeah. Cast. So what is this going on? I've never seen this. There's a dynamic casting? That is so crazy. Doesn't have read and receive into. Size equals length of buffer. But that will only happen if size is equal to 0. So if size was equal to 0, then it will get set to the length of the buffer. Else, it just equals itself. It equals itself. Okay, so if size is 0, it gets set to the length of the buffer. So this is literally what got changed here, right? We're really close, I think. Because it used to have this code inside the socket that said if buff size is equal to 0, then do a bunch of stuff. Right here, if buff size is 0, read as much as we can at the moment, it says in the comment, and it goes on to do this stuff. And then, but the new version does not take any of that stuff into account. It just says buff, byte array size, self-receive into that, return the bytes from buff. And this buff size equals 0, I gotta think is the same thing as this size here. Because that's even inside receive buff size there. We're in receive into instead of receive, but it's second argument size right there. Is there a receive only? Bucket. Buff size doesn't have a call. Okay. First, let's figure out where we change this and undo it, since that just broke. And we know that our thing is true, so we don't really need to print it anymore. It's always going to be true. Wow, we have a lot of functions with very similar names in here. Do we have receive into? Seems like it's gonna like bring data in and then store it inside of a buffer. We have read to. Okay, read to we learned before though. That's like read until. Read until you find this sequence. Read from buffer. Which seems like it's also receiving potentially. Read into. Like receive into and read into. What are the difference in those, I wonder? Iter content finally here, okay. Chunk size defaults to 1. Decode Unicode Boolean false. An iterator that will stream data by only reading chunk size bytes and yielding them when we can't buffer the whole data stream. Unicode not supported, byte array, chunk size, while true, self dot read into, so we're using that read into. Goes into size, and then here it says if size is equal to 0, break. Otherwise, if size is less than chunk size, then chunks equals, pretty sure this is basically copying it from one place to the other. Else chunk equals bytes. That would be if size was greater than chunk size. What's B? Byte array chunk size. Yield chunk. This is all inside while true. Whenever it breaks, that's when it calls close. Are we getting zeros more than we should or something? Size is always 64. But we also are using 64, which we found was not really having the broken order, just the messed up color sometimes in a certain band of it. So I will probably go back and change that here in a minute. Oh, interesting. This time we got everything correct. You know, we slowed it way down by adding the prints. I wonder if the color was like trying to go too fast, if that makes any sense. I don't know. But we got a perfect picture when we slowed it down here by adding this print. Let's go to the bigger one though instead of 64. 512. 512 I think is what the original code was using. I did try 4096 earlier as well, and it was still blocky. It'd be interesting to see what that does with this also. Place 512. All messed up. And going slower this time did not help it either on the color or the stair-steppiness. So I want to see this same thing get printed with the old version of ESP32SPI. Well, the real version currently, the version that's unchanged, the version that does not have those changes to make the socket compatible. I'm going to take current main. And a bunch of these now. Like 5 of them. Got it reloaded. Again. Okay, every now and then there's one that's different. I'll wait till it's finished to try to scroll back, but I can see it. Every now and then there's one that's different. I think I saw 448. So, you know what's happening? We're reading too far. We're reading too far, I think. With the modified version, we're reading too far. We're reading, so like here, the version that works is reading 448 bytes. The version that doesn't work is reading 512 bytes, which means that it's reading 64 extra bytes, or the difference between these two if it's not 64, which it's probably not because the 12 and the 8 should not make a 4, I don't think, but maybe they do. I don't know. Anyway, whatever the difference here is, we're reading too many bytes. And so then what happens is we read part of the next line down. which is why we're getting that stair step thing. Okay. What if we find where that special behavior is? Buff size 0. Do these coincide with, I'm assuming this will coincide with the 448s, the ones that are like this. So my guess is that this special behavior is happening on those iterations where we would have read less than 512. It is weird though, because we're not like we weren't getting zeros, so maybe it's not the same size I was thinking. Oh, some of them are even lower now. Gotta auto reload. Did not print any of those ones associated with it though. Never did print buff size was 0 though. Which means that never got flagged, which means why did removing that behavior break it? I mean, I guess a bunch of other stuff got changed as well. Yeah, a bunch of other stuff got changed as well. Maybe the whole time this was a red herring? Maybe the actual change that caused it not to work. But what did I say here? I said what? Made a version that reverts this change for the special buff size 0 behavior. What did you see past him? I wish I would have posted more of the code. So I'm not sure if that means that I put back in just this part here, or if I also put back in like all of this stuff here, which is not actually inside of the if statement for buff size 0, but was removed with the same chunk of code. Well, first of all, I have these old ones of these. 0 buff size. Past attempt might have left us this. Yeah, I put back the whole thing. I basically reverted the whole change to receive. So I kind of think I maybe started barking up the wrong tree way back here when I posted this, because it's not actually, it does not appear now that buff size 0 actually matters at all. Probably this bit matters more. And how do we prove that? We prove that by going back to the old version and cutting this out. And when I say old version, I mean current version, which I think of as the old version while I'm in mindset of this PR, basically. So I kind of adopt the mindset that this version will be the new version once it's ready. We could take this out, and I'm in the wrong repo. Okay. We could take this out, and it will still work the same. It's unclear to me if the bug lies within requests or portal base. And when I say the bug, really what I mean is it's unclear to me where the change will need to be made. Does the change need to be made in requests or in portal base? That part I don't know right now. Yeah, that worked perfectly the exact same way. So buff size 0 is and was always a red herring, actually. This bit's not important. It's the bit that's down here. This sounds like what we're having happen in the other case, where we're reading, like, I think we're reading too much on those iterations where we get the lower numbers with this version, like the 448 here, and there's a bunch of others all scattered throughout, but 62, there's a bunch of them. Any iteration where the version that works gives us one of these, the version that doesn't work gives us just another 512. And those are where I think it's going wrong. We received some bytes, but no more are available. Return what we have. That is where we're having a problem. This is gonna print right before those smaller sized iterations. That's the hypothesis now. How does this even work though? Elif, if available. Available equals self.available. If available, we go inside here and do this. If received. What is received? Delist. What gets added here? So basically, it will go in, available will be true the first time, it will do its thing, it will loop and loop and loop and continue appending things to here. Eventually, available will be false. And then as long as received has at least one thing in it, so as long as we went through this bit at least once, then we break. Which breaks out of this while loop. and ultimately does some stuff to the buffer and returns it, and garbage collects a bunch. Yeah, right there. Okay. Okay. We're gonna go back and comment here. Can I like multiple lines? Current socket behavior. We occasionally return less than the chunk size from iter content, iter response. Where that occurs, it's because this logic is causing it to break. But with the socket behavior from this PR, seems that we always return exactly chunk size. Never have those iterations that return a smaller than chunk size amount. I'm thinking that in those iterations, we're reading much data ultimately coming from the next I'll call it next row down the image, which is moving that stair stepped chunky effect. Okay. Let's update this file also with some stuff, because we've gone pretty far since the last time I wrote anything in here, haven't we? We last left off with iter content. Where did we... iter... So PyPortal, we're inside wget, we're calling response.itterContent, which is back inside of requests.py. What line? Oh, that was right there. Okay, 436. Which led us into, I think, receive read into. It led us into read into, which call read to remaining. I mean, this logic looks pretty relevant, right? This is a weird bit. So read into, no, read into. So we have read to, we also have read into. If not self-remaining, that's already weird. If not self-remaining, why do we want to do anything if there's none remaining? That seems backwards to me, but I don't know what's going on. Read from buffer, receive into. Self.receive into, I'm not sure. Somehow we ended up inside receive. Receive is the code. Socket receive. There it is. Okay, we finally have pulled the thread all the way through, I think, here. There's, I don't know where we just came from. Into. Iter content. So inside iter content, it calls read into. At 436, that's where iter content's declared, but it then calls read into. Calls self.read into, read into. At 4. Why would you close that? Is there an undo or like? I just can't click on anything. Shift Q is stuck down, I think. And now just like a squirrel, I don't know where I was at. Read into, we were trying to find the function. No, we were trying to find the line number, and I closed the file because the way that clicking works sometimes closes the file that you're trying to use. 444. West.py. That is at 276. At this calls this, which is read to? No. Receive into. At 309, it calls receive into. And it calls receive into, and then in receive into, finally, this is declared 219. request.py 19 def receive into at 222 calls socket.receive, which is where the actual change is at. Save this. So if we step backwards from there, we will find the places where we could implement a new change in order to work with the now modified socket. We could either do it right in, like the latest place we could do it is all the way inside of here. Actually, underscore. Right inside of here, we could add the logic that got removed from socket.receive. It's still a little bit unclear to me if backwards compatible, if that's talking about the compatibility that's being changed or not. That part I don't know, or if that's like a totally separate third thing that's not related at all. I'm not sure what they mean compatible. It was checking if it had a receive into, I think, right? So I guess at some point there were some sockets that did not have receive into. But ours does. Receive into in new version it also does, I think. Yeah, in the new version it also does. So no matter what, we are using not backwards compatibility. We could either change it here, or we could change it from where this gets called, which was 309. We could change it inside of here. Or we could keep going up the chain. So wherever this got called, we could add it here. And then ultimately, once we get to here, this is where we're printing out the sizes. Once we get to here, we need to have adjusted. We need to have done our fix because our size on those one iterations with the smaller ones, they need to be smaller. So honestly, I would say size is getting returned back from read into right here. So honestly, we really probably should not be changing size after we get it back from read into. That doesn't really make any sense. Because at that point, we would have already read too much stuff anyway. We don't want to just change the size after the fact, right? That's not going to do anything. So why does this logic not come into effect here? Number of bytes equals length buff if self-remaining and n bytes greater than remaining. If remaining, I don't even know what this means. Okay, this is like this. These are together, not this. Okay, if self-remaining is truthy, and if n bytes is greater than remaining. If content length was provided and remaining bytes is larger than buffer, n bytes equals self-remaining, adjust read amount. I mean, that sounds like what's happening when it does work correctly. Adjusting, the read amount is getting adjusted. Why don't we trip into this thing? I'm gonna take these back out. It shouldn't change the behavior, I don't think. I don't want to like modify it and then I don't even know. Content length was provided. Remaining bytes is larger than buffer. Remaining bytes. What is large is? I assume that's supposed to be larger. I'm gonna also actually print the values of these things because I don't really know what these represent. I don't know, is that a number? Is that how many bytes are remaining? Is that the actual text of the remaining? I don't know what it is. Remaining is this. N bytes is this. Yeah, that's fine. The other one is just the comparison, which we can see from that. What? Okay. Interestingly, when we hit these things, we don't actually trip our new prints. Only at the very, very, very end. Okay. Remaining. So remaining is going to be big. Remaining is going to be basically the full size. It's going to go down by 512 each time we read 512. How is that thing knowing when to stop reading and return what it has? Received. Saying that available was false. Available was false. Was available removed altogether? Or is that a thing that we can still use? It still exists. Well, but I'm in the old version. New version. Did I delete it this time? There is PR here. I guess I could update. Yeah, that's what I did at this. It's to underscore now. So that's probably non-standard. And how many bytes of data are available. And so, but because it's internal, like leading underscore, it means that we probably shouldn't be calling it from outside of here, but I don't see any. Okay, so old receive used to have all that logic. New receive now just calls receive into. BRB. I gotta go to the restroom. It would be interesting to try to use something else that uses portal base and wget, but has a ESP32S2 main chip. I wonder if the wget that is ultimately from portal base would have the same problem if you ran it on a ESP32S2 base thing or a Pico W base thing with the built-in Wi-Fi, which should have its own kind of socket. Because it feels like there should have to have been some code somewhere that says if we have an ESP32SPI socket, do it this way, and if we have a built-in kind of socket or a CPython socket, then do it this way. Since there used to be, or currently are, since there used to be different behavior between ESP32SPI and the other one, somewhere in portal base or requests or somewhere I would have thought we would find some, like, if it's this kind of socket, do it this way. But we haven't really run into that except for the backwards compatible. The backwards compatible kind of reads like that, but it's only checking if it has receive into. As far as I can tell, I mean, I think they all have. I guess let's CPython socket have receive into. That's one thing. Yeah. So, like, as far as I can tell, all of them pretty much had receive into. So I'm not sure when backwards compatible was being used. Buffer chunk isn't an even multiple of the packet length. Question mark. I'm not sure. I don't know what the packet length is. How's the remainder monitored? Yeah, I don't know that part either. I mean, in the old code, it was kind of like this, right? It was like this: if available became false, then it knew that it was supposed to stop reading and return what it has for now. And the new one, it always just calls receive into at that size. Inside receive into, the only change was to make available be underscore instead. And the old version was not actually calling read into at all. Old one was calling socket read. It's checking available here as well while available, and it's calling socket read more on the interface, whatever that is. Socket reads inside of here. New one is just receive into. Receive into, it does actually have socket read, okay. It does, I mean, it does make sense that we got rid of all this custom logic here. And now we just call receive into, which is like already doing the socket read. Like receive into, it seems like is a good place for this. But is... I mean, I assume we're not supposed to be changing anything in here either, though, right? Because if I understood correctly, the current state of receive into in this file is that receive into currently behaves the same way the CPython one does, which is what we want. So we would not want to just go add our special logic inside of there, because that's just moving the problem from receive to receive into, but both are part of the API that's trying to match. So we need to move it further out than that. Which means we need to move it out of here. It would have to be here. It would have to be... But this is the weird part, is if we do it here, inside requests... Yeah, this I think is what I was trying to get at, honestly, when I was talking about ESP32S2, is why this feels weird. If we make the change here inside of requests, it's going to affect ESP32S2. And my assumption would be that it will break it, because the way that it behaves today, to the best of my knowledge, is like it functions correctly. So if we change the logic like this, I got to assume it's no longer going to function correctly. So then are we saying we need to go all the way back up to here inside portal base? But this can't really make any sense, because it's just calling iter content, which is inside requests. And if we don't... Like, by the time we got an answer inside of this file, by the time we got a return from this function, it's already read. And so if it's reading too much, then it already read too much. But maybe, but we're telling it. Are we telling it how much to read? 11. Portal-based network. Yeah. So, but these aren't, so currently these are not changing, other than if minimum, like at some point the minimum flips. At some point the other one is smaller. But that's the only time they change. If we could somehow get them to change on those iterations when it returns less. so that instead of 512, it would know to pass. But would it be remaining? But this is like the full thing somehow. So how were these knowing? How were they knowing not to be 512? This inside inner content, where are we printing? The inner content size came from read into. Is chunks, so chunk size is what got passed. Is that changing? Chunk size is chunk size stays the same. Always 512 until the very, very, very last read, which is when it would flip to be remaining is less than chunk size. So we're always passing 512 to iter content. But occasionally the amount we get back is less. Okay. I think we need to test built-in Wi-Fi. I think we need to test built-in. Wish there was an easy way to just get the exact same thing that I just put in, but like fix it the one character that I messed up. Can we call wget from this? That's just a quirk of the documentation? Is that because it's extended? Like, does this one say wget? Okay, that one doesn't either. So it should work the same. We went through one of these files, did we? This Jane. I do kind of remember being inside one of these, though. It was not working before I called connect. Must have been we were. Oh. Okay. This is on network base. wget. So we should be able to call wget from any of the rest of these. Magtag or funhouse. Okay. BRB. I'll take this code. Okay. So if this is going to tell us kind of where we are ultimately going to be changing code to make the fix, because if this one is also broken in the same way, then we need to be changing code inside of requests. Potentially. But I'm going to second guess that statement, so who knows. Second, I'm also going to look and see. Look and see if the picture that it downloaded is also broken. Well, yeah. Obviously it's not, because the most recent one I did was with the working version of everything. I want to confirm that the file is actually messed up when we look at it on my computer. And then if that is the case, we run the code that is as close as we can get on the funhouse, and we find out if the file is messed up in the same way or not. And I think this will tell us something about where the fix can go, but I don't know, maybe I'm wrong. We want to get back to the broken one, which is the hat socket one. I think I am just going to delete this so that we don't end up with yet another copy in a sort of questionable state, because like I think I was like modifying with prints and things in here. Do we want to keep the current with my prints? All right, how about we compromise? Let's delete unknown. This one. That socket is this one. This should be the one that is giving us the broken image. Which we then want to check. Maybe it just reset like while it was in the process of renaming that thing. Nope, it's definitely just broken. Okay. I feel like it was running before it was like done renaming this or something. Yeah, it's like continuing on now. I don't know why we're lagging by that long, but so this is our broken version where we're going to see 512 every single time, no matter what. Broken. Also have be broken on the colors as well. So I'm going to unplug this. Yeah. Okay. Complicating things a little bit. The Funhouse does not have an SD card. So we need to make drive writable. This is a test inside of a repo. This is from Dash Display. I need to keep it. All right, we're not going to want PyPortal. Or no, let's actually call it the thing it is. I could stop printing this, honestly. It's not doing anything. It's like gonna be too big for the screen, but whatever. We're trying to take it back off of there onto the computer and look at it. How big is this? Space do we need to make available? Be pretty tight on the space, I think. 193K. Oh. Ouch. Okay. Well. Here we go. We're gonna copy everything. The old Funhouse backup action here. I don't know why I called it backup when like every single one of these I did not actually say backup on, but and we're gonna have to just find some stuff to delete. Images. Letting me go to yes. Oh. Such an unnatural act. E left enter. E left enter. Or we're bothering with, I don't. Bytes a piece. Let's go back up to bigger fish. Trash, we could delete the whole thing. I don't know if you can delete folders from inside of this thing. I don't know if it's like live or it doesn't look like it. We refresh. I don't know. Let's just rerun it, I guess. What are we looking at? Total space, parent size, free space. I don't know. You have to subtract yourself, I guess. 218. We're close. Need another 80, 90 something. We want to clear up at least 100 or so to be safe. LED animation we could delete. Portal base. Is it frozen in? Because if so, we could delete it extra hard because it will not matter at all. It's not going to get used if we have it in the lib folder. I wish there was a way to know what's built in, frozen in. What if we printed a list of the things frozen in inside boot out? Cool, I think. It is in requests. So yeah, we can delete that because not only does it take up a bunch of space, it's not even getting used, and it never has been getting used. Same thing for this. LED animation real. I don't know why we had a different one, but that's all right. Yeah, I don't even know why this would be on here. That's not usable on this device. Jumping through some major hoops. DPS, we could delete. I don't know, we don't need it. Display text. Dash display. Any MQTT image load? Yeah, we can delete both of those. We're using on-disk bitmap. We're not using MQTT. The animation real. I mean, we probably could. Not requests. Funhouse. Strikes me as odd that these have portal base and requests frozen in, but not Funhouse, or on the other one it was PyPortal. I'm going to delete Funhouse because we're going to reinstall it to get the latest version. What are we looking at now? 600 free. Okay, that should be plenty. Let's update CircuitPython. I'm gonna get to bootloader. Oh, I still did it wrong again. Gotta do it when you gotta push the second one when they're purple, when the lights are purple. My instinct is to go a little faster than that. What else is fun? Hello, everyone. How's it going, Dexter? Good day to you. Oh, it like appeared right when I was trying to click. Okay. So this should be failing because of some things. Let's start fixing those things. And the last one of those things is going to be because it can't write to its own drive. But also we don't have the library right now probably. But also I don't even know the right import for the library, so... You do need a capital H. Could fail because we don't have that. We'll circup it. And at some point we'll fail because we can't write to the place where we asked it to, I believe. Module. Maybe that was taking a minute. I don't know. Maybe I went too fast. All right, BRB. Funhouse has no wget. Would Funhouse have no wget? And the PyPortal did. I didn't say, did I say network wget last time? I don't think, did we change that? Just PyPortal wget? Does this not extend portal base? Does? I am... Didn't we see some code somewhere that said wget equal? I see. Okay. In PyPortal, it has this thing basically overriding self.wget with self.network.wget. Funhouse does not have the same thing. So therefore, you can't do funhouse.wget. But it still has network, and network is still a network base, and network base should still have a wget. So we should be able to say funhouse.network.wget, and that should be doing the same thing ultimately. What it was before. Late for coffee. I had to take care of something else this morning. How's it going, DJ Devin? Eventually use another coffee. Okay, finally we made it to failed for read-only file system. So we don't have an SD card, so we can't just download it to the SD card. But we can make a boot out the boot file, boot py, that makes it be countable or whatever. I want to make sure the buttons do have the polarity that I want, basically. Because what I'm going to do is make it so that when you hold down a button while it's booting, it will go to normal mode. But when you don't hold that button, it will go to writable mode. We need to make sure we know which one is which, though. Otherwise, they'll be backwards, potentially, at the end of the world. I don't want it to be that way. Button, let's just say button down, then. Didn't save it. Okay, current value is true. I'm not pressing the button. Let's see if I switch. That's awkward. Stays true. This is why we did this first this way before we hooked it up to the remounting, was to get this actually working. My guess is we need to pull down, probably. That's not going to rerun itself. There we are. Okay, so now we have it so that this comes out false when we're not pressing, true when we are pressing. This is the exact, I'm so glad I tested this. This is the exact reason I wanted to run this before I actually just hooked it up to the storage. Storage.readMount command has a read-only keyword argument. This argument refers to the read-write state of CircuitPython. It does not refer to the read-write state of your computer. When the physical pin is connected to ground, it returns false. The read-only argument in BootPy is set to the value of the pin. When value equals true, the CircuitPy drive is read-only to CircuitPython. So when we pass true right here, we are saying that CircuitPython will be read-only, which is normal. That's the typical way that it usually works. When that's false, CircuitPy drive will be writable by CircuitPython, not writable by the computer. I'm gonna make not boot first and then copy it into boot so we can like save it while we are writing it and not have it like try to run. Okay. But this was true when we press the button. Yeah, that's what we want. So when the button is not pressed, this value will be false, which means false gets passed to here, which means CircuitPython, the code, will be able to write to the drive, which is what we want. When it's true, which is when we're pressing the button, then it will be normal mode, which means CircuitPython will not be able to write, but the computer will. Which should be the logic we have with this. So inside BootPy, if we are holding that button down, we'll get the normal boot. Otherwise, we will get the writable mode. We could maybe print out, I don't know if it matters, but I need to reset button in order to get it to actually go though. So I will not press the button this time. Theoretically, that means it should boot with it being writable to CircuitPython. Means that it should be able to download this file. Then it will try to put it on the screen, but it probably won't fit. Could change some of the stuff in here to make it fit maybe, but it doesn't really matter if it fits on this screen. Oh yeah, also my Adafruit IO key, I guess, may or may not be visible, so please don't steal it. Does feel like a slower download. But the main CPU is doing more work too. Not a lot of, yeah, no, not at all. I had to delete a bunch of stuff a few minutes ago. Yeah, we just went on a machete through the jungle a few minutes ago to knock out enough space. Yeah, I would never probably like set up a project to work this way on the Funhouse as a long-term thing, but we only need to just download it once and see how it comes out. Okay. Finished downloading, and it does look fine to me on the part that did make it onto the screen. But it is definitely not very much of it. Doesn't show up in here. Need to do a I mean, it has to be downloaded, right? It has to be there. Because if it's not there, then the OnDisk bitmap could not have drawn it. So we're just like not, the computer cannot see the current state of the drive, which is interesting. So now what we need to do is kind of tricky. Right now what we need to do is get it to reset, because I assume after it resets, then we'll be able to see the file, but we don't want it to run again, because then it's going to start downloading a new copy of the file, and I want the full one. And I can't just change it here because this is now read-only from my computer. So I guess though, if we press the button, then we should boot to normal mode, which means it should fail to download, which means it should not overwrite the file. Okay, so hopefully our thing works. That's gonna be the solution here, is hopefully our down button actually does what it's supposed to. I'm gonna hold down button, press reset, down button. Would be safe to let go of it at this point, I'm pretty sure. And I think this should fail. Yep, read-only file system, that fails, okay. Hopefully we have the actual files now. Yep. And it is fully completed and fine. Does that tell us about where we need to make our fix, though? Because both Funhouse and PyPortal are using both requests and portal base. So if we make a change in either requests or portal base, they both start using our change, which is probably bad because right now one of them works and one of them doesn't. So I assume we just flip-flop. If we make a change, then the other one works and the one that does now doesn't. I don't know. I'll be back in a minute. Okay. Yeah. I don't know what this tells us now that we're here. Because both of our choices to fix it get used, but somehow Portal Base uses that. Oh, Portal Base uses these things. Back to the PyPortal. So Portal, where I'm so confused, because Portal Base has to be able to handle the correct socket API. In order for that funhouse to have downloaded a proper looking image, that tells us Portal Base must be able to handle the correct socket API, which is what the new ESP SPI is set up to behave like. It must be able to do that, otherwise we would have got a broken image. So somehow inside of Portal Base, it is deciding which thing to use, and that is somehow leading to broken image on one and not the other, which I guess has to be in those files. Where's Portal Base? Used. This is class Wi-Fi. These have to factor in somehow. Class Wi-Fi. This is coprocessor. Class Wi-Fi inside of a NIT. Status LED, we don't care probably. Request is none. ESP equals ESP. So if that got passed to us, then we're just going to set it there. If it didn't, then we're going to go and initialize it. We're going to assume it's on these pins. We're going to use the SPI that got passed to us if it did. Otherwise, we're going to use board SPI. We're going to initialize ESP SPI control as ESP. We're going to request.getSocket. I think is the old API. I think session is supposed to be better, but that's neither here nor there. This would be socket. What is socket? Where did socket come from? Oh, okay. It's the socket class. strangely has a lowercase s. Okay. So we call setSocket equal to basically the constructor of the ESP32SPI socket. And that's what we put on requests. And then we also gave it the ESP control. If ESP is connected, then requests equals request. So if we're not connected, then request is going to stay none, self requests. What is requests then? Oh, this is the import. So we would call setSocket, but then we wouldn't put it onto here. Manager is none, collect. Okay, inside of init here. Status LED stuff, request none, pool none, connected false, collect. Nothing else happens in this one. Notably, we haven't called setSocket yet. Where do these get used? That seems highly unlikely. Okay. Inside PyPortal network Pi, it imports this, and I assume Funhouse, same thing. Okay. Okay. So after init, we do have a difference of, with the coprocessor, by the time that init is done, we will have already set socket on the requests library. We also will have checked if we are connected. I assume that means to the network, but maybe it doesn't actually. Maybe that's a false assumption. Maybe this actually means like main chip is connected to ESP chip, not collectively they're connected to the internet through the ESP chip. How could we find that out? By looking at the docs for ESP SPI control. Is that supposed to mean connected to the ESP32? Or is that supposed to mean connected to the internet? It's got to be the ESP32, I think, right? Connected. Whether the ESP32 is connected to an access point. No, okay, so it is connected to the network. It could be a network that's not on the internet, but it is connected to the network. So if we are already on a network, then requests gets filled in. Otherwise, it's going to stay none, and it's not going to be able to work. So that's a pretty big difference between the ESP32S2 and the coprocessor version, is that inside of init on this side, we have not touched requests at all. Requests is still none no matter what. So we're not checking if we're connected. We're not initializing anything. We're not set socketing the requests. I didn't mean to close that. I don't even know what file it was. That's awful. Okay, well, so we'll open it back up if we ever find it again. Network.connect. So we did have to call this in order for it to work. Process image. whether or not we have an SD card. Maybe here is the answer to our change. Inside process image, it's going to call self.wget is actually network wget, which is actually going to network base. This is in PyPortal. Does it have different code in the Funhouse network? Process image? And process. Network base have process image? Oh. Interesting. I didn't know that. So PyPortal has a process image, but none of the rest of them do, or Funhouse doesn't at least, and base doesn't. Process image is where we're inside of in the Cleveland art project. In my reproducer here, though, we're not inside of there. We're just in wget, which means that we can't fix it inside process image because that would fix Cleveland art, but this reproducer would still be broken. Okay. Keep tracing through this. So we would have called connect next here. In coprocessor version, that would have just said ESP connect and then whatever SSID password, and then also there it would say, I don't know if I just moved something. Then it's got request equals request. Processor, which is kind of weird because it would already be that way from this, but I guess maybe this is implying that obviously implying we weren't connected, so. Yeah, here's where the other difference is, right? So in this one inside connect, that's where we're getting the socket, and that's where we are essentially doing set socket on the requests, although this one is using the newer session instead of set socket. Is there any possible chance that if we just use the new version of this instead of set socket, that everything will just work? Is that wishful thinking? Is that even possible? Can you use the session style one? Maybe not. Where did portal base go? It's not right. Time to start thinking about calling it quits for now. Might be needing a break here. That just call set socket. Where did we see that? Didn't we? We said it. We saw somewhere that it said it was deprecated. Set socket. Legacy API for setting the socket and network interface. Use a session instead. Fake SSL context. I mean, this uses session under the hood, so we could, I guess, do it the same way with fake SSL context. That's not going to change anything. It's not going to change the behavior of the download, I mean. Because we just saw inside of set socket that it is just turning around and doing session. iFace, which we did pass. So it is calling session with the socket and then this thing. I don't get it. I don't get how this is working on the funhouse, basically. We keep going here, it's done set socket requests, but then over there it doesn't happen until connected. In connect. All the more that's like in this file. So there's a difference of when we set the socket onto requests, but beyond that, there's no other like grand logic inside of here that says like, if the socket is this kind, then do it this way. But if the socket always had different behavior before, the ESP socket behaved one way, the ESP SPI socket versus the built-in socket, if they don't behave the same, they didn't used to behave the same. With this PR, now they do. There has to be code somewhere that was accounting for that difference. Otherwise, it couldn't work on the funhouse. because now the sockets supposedly behave the same. Requests. That's the one I closed. Did it get deleted? Is this where backwards compatible is? Did this ever say anything more? This doesn't really say very much. I'm back around to wondering, is backwards compatible talking about these two different socket behaviors or not? It failed when we set that to the other thing. Maybe we should have checked what it printed on Funhouse. Add backwards compatible API. Make SSL socket. Okay, this whole class is the backwards compatible. Has much less stuff now. Oh, those aren't part of the class. Wait a minute. How do we have two? Oh, this is context. Okay, backwards compatible was the context, not the socket. Actually, this thing. And all the stuff below it. So when it was originally written, this part was not actually included. But then when this got added, it got added under this, so it's unclear. I don't know, maybe if this is still part of that or not, I don't know, but wrap socket. Fake SSL socket. And this is where our set socket is at, which is where the thing we just looked into before. It's where request calls it to default session, and it's where all of these just call it to default session. So it's like the first layer that we had in here. It's like the most outer one inside requests right here. It's basically this backwards compatible thing. I figured it out why my feather wasn't updating using continue instead of break, so it was never going out of the IPv4 loop. If it fell inside, it would just hang. Gotcha, yeah. Break to get out of the while loop. Nice. Yeah, we saw that in one of them. The read loop, I think, somewhere in there, it's doing that. Okay, I think we leave another comment here with my current understandings, and probably I think I gotta call it for now. That. Both of those libraries are also used by a funhouse by house library. I have confirmed that funhouse.network wget is able to download successfully out stair problem. So any change that we made side of either of those places seems like it would result changed behavior if the funhouse were to call wget. I'm guessing cause it to break since it behaves correctly right now. It's correctly right now. If we change its behavior, then it stands to reason it would be broken. Okay. Where would we leave? Good time to harden. Having a lot of, there we are. Okay, having a lot of internet connection issues lately, up and down all day. Working in the area this week. See the trucks everywhere. Great time to harden. For random fills, yeah. Yeah, that's actually kind of a blessing in disguise in some ways. If you're trying to write your logic around that stuff, if it won't fail on you, it's tough to know where to put stuff. I do have that issue in my day job sometimes. But assuming it's still connecting now, breaks out of the while loop, reinstantiates the entire thing over again. And a good amount of work from today. Yep. Yes, that is definitely true. It's definitely a bit of a maze, but I feel like I'm getting a pretty good understanding of where it's at. We got to be pretty close. I feel like we got to be pretty close, but not quite there yet. Got to figure out where. Yeah, it's just tricky to find out where we can make that change to be to make it still work. I'm honestly a little surprised it works on the Funhouse. I was kind of expecting it to fail in the same way and just have never been noticed. That's not actually the case. So somehow we need to work in a spot where we can have this non-standard behavior, but only for the ESP32SPI, which still feels like it's broken somehow since it's supposed to be equalizing the API, but I don't know. Today's stream gave me a couple tangential things to try to resolve some pesky corrosion monitoring. Right to AIO issues. Nice. Glad you picked up a couple potential tips inside Portal Base. Yep. All right, I'm gonna head out for now. Thanks for hanging out, folks. Thanks for chatting along in the Discord here. I'll be back at some point. I don't know exactly when. I mean, certainly on Friday, possibly on Monday, maybe tomorrow at some point. Who knows? You can always follow me on Twitch if you want the heads up when I do stream. Hopeful seeing about how you go about problem solving, picking up mental tips. Yeah, that's good. I'm happy to show the troubleshooting and the kind of like reverse engineering of this. I'm happy to wade through all of the waters here on stream in a way that is hopefully helpful to kind of like communicate the process that I use for breaking stuff down. So that's good to hear. Thank you for that. I appreciate that. But yeah, I will bid you farewell for now. Hope you have a good rest of your Saturday and a good weekend and all that stuff. I will see you all next time. Thanks again for watching.